Double check and make sure I'm not missing any evens. I think I have the right numbers. I just have it from last year's, and this year's has changed as far as the number. Let me get the new assignment real quick so you guys don't get confused on the video or in class. All right. Delete and copy. Okay, number 2, sample space. Number 4, impossible event or certain, I think I might have said guaranteed in class. I don't remember. Certain, guaranteed, they're synonyms. We're okay either way. Number 8, 3 and then 1, then 4, then 2. 3, then 1, then 4, then 2. Number 20, you were supposed to figure out all of the different, I guess the easiest way, figure out all the different possible ways 3 coins could land. Is that right? Such that the condition is true. Such that the condition is true. So to have at least 2 heads, wasn't that the condition?
Yeah.
At least 2 heads. Either all 3 would be heads, or the first 2, or the last 2, or the first and the last. So 4 out of 8 total possibilities, which could be found by 2 times 2 times 2. 2 options for the first flip, 2 options for the second flip, 2 options for the third flip. 1/2 or 50%. Sometimes we did fractions for probabilities, sometimes decimals, sometimes percentages. As long as you guys know how to tell the difference, we're okay. Number 44 was the next even. And then 52 and 60. Okay, number 44. There was kind of a lot going on in 44. But for the condition, there was an and, which is why we had to multiply 2 different situations. Out of 8, choosing 2, and out of 100, choosing 5. Was this one of those defective problems?
Yeah, defective 3 is different.
So I'm guessing there were 8 defective and getting 2 of them, and then there were 100 non-defective getting 5 of them. And then the total was out of a total of 108 getting 7. Now they went ahead and used factorials, but kiddos, this kind of problem would not be a by hand problem. So you could have just thrown that in your calculator, right? NCR, math, good? Letter B is very similar to this one. You have 3 different things going on. So you have out of 8 having 2, and out of 25 having 2, and out of 25 having 3. But you have the same out of 108 having 7. Once again, they showed the big old formula, but once again, I would say this would definitely be a calculator problem. Now, if there was a shorter NCR tomorrow, I might have a fill in the blank, show me the formula. If there was a shorter NCR. Number 52, when we get here, they show the complementary event as E with a little apostrophe. You could also show the little, I don't know, little tilde, little NA without an N. That's my notation for it. I guess they like to do the little apostrophe either way though. Complementary just means take the probability of the event, subtract it from 1 and get what's left over. I would have said 64%, they put 0.64, the decimal instead. Either one's okay. And then going down number 60. They have it written as squared, but remember you could have done it blank with blank. And then had the probability of the first event happening 90% and, which would be multiplied. The second one should be 90%, which is the same thing as it squared. Not happening would have been 10% and 10%, or 0.10 times 0.10, that's why they have it squared again. And then letter C, you could have figured out the at least by counting up all the different ways it could happen, which could be pretty complicated. Or you could just say, what's the probability of it not happening? Take away from 1 using that complementary principle and get 99% left over. It was the fastest way. Not the only way, but the fastest way. Questions on 9-7? Probability can be tricky. Caleb?
31.
31? Okay. Any other odds or evens?
47.
47? Anything else? I think my Adobe just kind of crashed a second ago, so let me get the book back open. All right, kiddos, while you wait for me to pull up 31 and 47, let me go ahead and let you guys see. A test review. No, that's not you guys. You have a quiz review. Let's go find it. It's shorter. There he is. It's called a quest technically. I think it's only worth like 25 points.
Only?
The last one was worth, well, the last one was worth 75 points, the 9-1 to 9-3. 9-5. There's only 6 problems, because probability ones take a little while. Let me give you a second to write those down. Meanwhile, let me get 3147 ready.
Oh my god. Let's use fair
For the most part, yeah.
Go get my.
I'll give a couple hints. If anybody needs to go grab their calculator or their textbook, I have a couple. I have one. I have one textbook left over. Go to your locker quickly if you need to grab something. It's a Monday. We'll get there. Yes, but I'll give you some hints about there's going to be some fill-ins, kind of like last test. Does that make sense?
Can you have someone stand at the door and ask me what the password is?
Have them do the secret knock?
Yeah.
That'd be fun.
Spoiler, the secret knock is a single knock.
All right, I have 31. Let me get 47.
Yeah, I just didn't remember how to do that, so I'm not.
All right, so everybody can make it back? Oops, Elaine's still coming. Is Maddie here today? No? And then Abby, who's usually in front of you?
Tyler sits there and I sit there. Tyler
Yeah.
sits there.
And then JJ's there. And then Nadia's gone today. So Maddie's gone, Nadia's gone. That's it? All right, kiddos, let's look at number 31. Someone had a question on that. Elaine's still coming, I think. Oh, where she went. 31, drawing marbles out of a bag.
I told you.
Without replacement, that's important, yeah?
I suppose.
Probability for the experiment, drawing 2 marbles at random from a bag containing 1 green, 2 yellow, 3 red. Both marbles are red. Guys, if there's no repeat, are we allowed to use combination or permutation, whichever one's appropriate?
No. What do you mean no?
If there's not, yeah, this is important for tomorrow. If there's not a repeat, if repeats aren't allowed, if replacements aren't allowed, then we are allowed to use combinations, permutations. Think of finite set of numbers for a locker permutation, or finite number of toppings for a pizza combination. Okay? So without replacement, although I guess a combo pizza you get double pepperoni, lots of struggle. Don't use that example. Anyway, so without replacement, combinations, permutations are legal. So for this example, we know we can make a fraction because it's probability, right? How many total marbles are there for our sample space? Doesn't matter the colors, just total. I think I see 6, right? So we have 6 marbles, and we're choosing how many? 2. Why did I choose combination? Are you picking one and then another, like in a lottery, how you're doing one number and then another? Or are you just drawing 2 marbles?
How does that?
It's a good
How does a
question.
lot?
I would assume, huh?
How did the lottery ticket for?
Well, I was thinking like the balls, and they're like, the first number, burp, and the second number, burp.
Did the
That's
same
It
thing goes on the
doesn't
side of the
matter
board.
how you pick them out, it's like one rather than the other one.
Yeah,
that's true.
it's not like you said, you pick one yellow first and then a red.
The order doesn't matter, right?
Yeah, no, you just pick 2 red.
Because you're just picking 2 marbles. I just see it as you're picking 2 marbles, kind of like you're picking 2 cards. I don't know. So, since you're just picking 2 marbles at random, order doesn't matter. We can use combinations. Both marbles are red. What goes in the top? No, not 6. That's the bottom, because 6 total marbles, and we're picking 2 of them.
2, 3? Is it 2 exclamation point, 3 exclamation point?
No. What's the first number? The total number, or how many we're picking? Total number. So on top, how many total red do we have? No.
Oh, 3.
We have 3 total. You see it? You gotta look at the restriction from the beginning. We have 3 total red marbles. Now, how many are we choosing? How many are we picking? 2. So we're trying to see how many different ways can we get 2 marbles out of how many different, well, 2 red marbles. Out of how many different ways can we just get 2 marbles at all? Does that make sense? And then Caleb, does that match up with what it's supposed to be?
I think so. It's supposed to be 1 fifth.
I think that'd be right. It would be 3 factorial. Hey, this is a good one for tomorrow. Once again, like the earlier ones that we saw when there was tons of combinations and big numbers, that wouldn't be by a hand problem. You could use your calculator. This one, I'll probably let you guys have your calculator out the whole time tomorrow, but if I wanted to test that you actually knew the formulas, what could I ask for in the question?
Right work.
Yeah, I could say show the formula, or show what you would need to solve by hand, something like that. In which case, how would you keep going, not just using your calculator? 3 factorial all over.
3 minus 2 factorial.
Subtract, which would be 1 factorial. 3 minus 2 factorial times,
2 factorial.
good,
That's basically just,
right?
that's just 1.
It's actually gonna be 3,
Oh,
because that's
yeah,
1,
stupid.
that's 2 times 1, so this has 3 times 2 times
Yeah.
1, and 3 will be left over.
I fell down.
You're okay.
It's 15.
And on the bottom, someone's already done it for us, it'd be 6 factorial over 6 minus 2 factorial, 2 factorial. Okay, so how important is it to study? Eyes on me, eyes on me, eyes on me. Some of you don't like to listen to my advice. How important is it to study the NCR formula?
A good deal.
How about the NPR formula?
Pretty important too.
Now, is it important to be able to push the button in your calculator?
Yeah.
Be able to read a problem and get to this? Yeah.
Yeah, that too.
But if you get this, don't lose points by not knowing this formula, because I'm gonna ask you somewhere to fill it in, I almost promise. Meaning, could be the NCR one, could be the NPR one, could be both. Okay, so highlight those in your notes and study them tonight. Those of you that somehow think you're not supposed to study for math tests, I don't know what world you're living in, but it's not ours. Study. Down here we have 6 times 5 times 4, those will cancel, 6 times 5, 2 and 6, 1 and 3, 3 and 5, 15. Good, and Caleb, you said 1/5, right? 1/5?
Yeah.
Good. Or 20% or 0.20. On the test tomorrow, the multiple choice, just keep an eye. They might have fractions, they might have decimals, they might have percentages. You guys should be able to make them all match. Let me get rid of this guy, he's kind of in the way. There we go. Number 47, Yvette's question for microwaves. The shipment of 12 microwave ovens contains 3 defective. So, hold on, if there are 3 defective, think it out. How many good ones are there? 12 minus 3 is 9, good.
That's good.
So we have 12 microwaves, of which we have 9 good ones, and we have 3 bad ones. They don't tell you you have 9, but just kind of process of elimination, you have 12, 3 are bad, 9 are good. A vending company has ordered 4. Because each has identical packaging, the selection will be random, so no one knows which is which between the good and the bad. What's the probability? By the way, it's an awful percentage if 3 are bad out of every 12. Anyway, what is the probability that all 4 are good, exactly 2 are good, at least 2 are good?
Just go to different companies where they don't have malfunctions and then.
Just pick a different company? Not sure if you know that this percentage of bad before you order from them, although now with Amazon reviews, hopefully. All right, all 4 good.
Gummy bears.
What'd you guys do? 12C4? Oh, for the probability, I mean, you're a fraction, so we have 12 total microwaves, microwaves, I can't say this one. They're getting 4 of them. That's total, 12 total, getting 4. All good, what's gonna go on top?
9? 9, 3?
Yeah, take the total, remember N is for total. So 9 total, C 4. 9 total, and out of those 9 good ones, you're getting 4 of them. So how many different ways can you get 4 to good? Out of how many different ways can you just get 4 in the microwaves? Now, for letter B, it says exactly 2 units are good. Well, what does that mean?
Exactly 2 units are good.
If 2 are good, then if they're getting 4 total, 2 must be
Uh,
bad. Which means still 12C4 in the denominator. All the different ways you can get 4 microwaves. But on top, I need to think about, well, hold on. Out of the good ones, I only get 2 and multiplication, right? Intersection of events. How am I going to finish this problem?
And 1 back, which is 3 more.
There. How many are they getting total? So I've just gotten 2 microwaves. I need how many more?
2, so
Yeah.
3.
So out of the 3 bad ones, I need to get 2 of those as well. So out of the 9 good ones, I get 2. Out of the 3 bad ones, I get 2. So exactly 2 good ones, and, well, I must have gotten 2 bad ones. And then on the bottom is the same sample space of, out of all 12 of the possible microwaves. Choosing 4. Letter C. This one is a little bit trickier. At least 2 are good. I think I have like this could happen, or that could happen, or that could happen, which has a mathematical operation, right? So what's one way I could get exactly 2 units that are good? Sorry, at least. I apologize. At least 2 units that are good.
A plus B plus,
Good, because A says all good. Isn't all good at least 2? So that would work. Or, okay, so if I get all 4 good, that's at least 2. If I get only 2 good, well, that's at least 2. Well, what's the other way this could happen?
Oh, I get it.
and then you add, 9, 3. No,
Yeah, what
9,
if I get
3
3 good ones, which means how many bad ones am I getting?
1.
Mhm. Now if you guys notice, the denominators are all the same, so you could technically just do this guy plus this guy all in your calculator divided by 12C4. Common denominators, I can put them all together. And then solve from there. Does that make sense? Does that make sense? Okay. So 31's been answered, 47's been answered. Some of you, I'm a little scared because I don't see some homework spirals out. Actually, quite a few. We've only had 2 sections, so we need to be working. But first of all, let me give a quick hint about tomorrow's test. Sorry, I keep saying that. Quiz. All we covered was 9-6 and 9-7. Let me get out of this just for a second because you guys already have that. Let me get back to our notes. Some of you might have missed a couple of the days or parts of the days, or you were not mentally here. Your body was, but your mind was not. Last week was a busy week for a lot of you guys. So the notes are online. I'm just going to go really quickly to nothing really to memorize. If I were you, get out a quick highlighter because we can make this quiz a good one, okay?
Yeah.
Let's make this quiz a good one. Nothing really to highlight on the first page, I don't think. Elaine, let's get those notes open. Let's highlight some stuff, okay? So nothing to really memorize on the first page. Second page, I would highlight this example, the integer example. He's a good one just to peek at and make sure we understand. That was kind of a logic one, thinking through all the numbers, picking out the ones that work. The idea of and needing multiplication is important. The idea of and needing multiplication is important, and our examples are actually pretty indicative of any fundamental counting principles you might see. Whether with letters, sometimes they stay the same if repetition is allowed. Sometimes they count down if either I have like a finite number of tiles I'm using, so once I place one I can't use it again. Or if they just say no repetition. We did, we did the words, we did the license plates. I would say probably highlight this one. With the numbers and the restrictions, that might be a good one to look at. Okay, permutation, make sure you highlight, order is important, that's something that's probably pretty good to get down, but also the formula. Remember, I might ask you to fill in the blank. You can use your calculator to solve, but you have to be able to read and understand the problem to get to the final answer, yeah? So permutation, 2 things, the formula and order is important. Otherwise, it's good to look at the examples. And if you guys don't write them all out in your notes, I would probably go online just to be like, okay, do I understand? Maybe like get a piece of paper or something, just cover up the screen. get the example, do I still remember how to do this and why we're using permutation? Order is important. Repeated objects. Ooh, highlight this one. This is one that kids forget to study. Repeated objects. The easiest way to study, don't memorize the formula. You don't have to memorize. I don't even like how they write it per se. Study the examples. Do you remember what we did? How many orderings of all the different letters, but we had to divide by the repeats. We had to divide by the rearrangements that wouldn't have made a difference with like the 3 B's or the 5 T's or the 2 A's in algebra. I especially like this one. What if you don't use all the letters? Use a permutation, then divide by the repeats. Oh, that one's good too. Combinations, the formula shouldn't be new because you guys are supposed to study it for binomial theorem, right? The order is not necessary, not important. Like a committee without a president or vice president. Maybe a good note to make. A committee where you do choose positions, like president and vice president, it could be a very different committee if George Corey was treasurer, not president. And Lauren Farrell was president and not, I don't even remember what all their positions are. But I'm just saying, like, if you switch it, they have different roles, and so it could change. And so if you switch the order of the positions, order is important. So if there are, like, presidents, vice presidents, and all that jazz, I would say permutation. But if it's just a normal committee, like a group of things, or a combo pizza, we'd use combination. Order is not important. Then we just saw in section 9.7, I wouldn't necessarily, once again, memorize the probability of formula, but understand we need to figure out the number of ways the condition can be met over the sample space, over the total number of ways it can occur. Probability is a fraction, it's a small number. I don't think I specifically asked you about these two, but it might be a good idea just to remember if the probability is 1, it must happen, which comes back to complementary events. We'll see in a second. I would make sure you know this formula. Maybe I'll ask for it, maybe I won't. It's more of an understanding of if you have probability of A and B occurring, multiply those probabilities. Maybe it's just multiplying combinations like you guys just saw with the 2 good and 2 bad microwaves. But maybe they give you the decimals and you're just multiplying the decimals to solve percentages. Then we just have or. And this one, watch out for the overlap. Watch out for the overlap. Our example was if I think a kid was wearing jeans on Friday or had brown hair. We couldn't just count up all the kids wearing jeans, count up all the kids with brown hair and say, yay, we're done. Because what about the ones that had both and were counted twice? And with that, kiddos, the last thing is just the complementary events. The chances of something not happening. In the book, they use a little apostrophe. I use a little like. Little tilde, tilde. Anyway, okay. Just to subtract define. Tomorrow, the point isn't for you guys to define stuff. It's not for you guys to use all the snazzy wording of mutually exclusive events or independent versus dependent. Talking through what a combination or permutation is. Maybe it should be, but it's not. It's more just examples. Kiddos, this is one example we didn't get to, but the microwave example I think is a better one looking towards tomorrow's quiz, so we just won't do that one at all. We'll just skip it. Let me get back to your guys' review, which is written, I think, right there. Are there any quick questions about what to study, what not to study, what types of questions will be on there? You may have your calculator, but I'm going to ask you to fill in the blank a few times at least. Mostly multiple choice, maybe a long answer to the end. 1 page from back. Mostly, maybe a long answer. Maybe even a bonus at the end. Are we good? Okay, remember, on reviews, don't have to write directions or problems. Show me the work and see if you can get it right. And kiddos that are behind on homework, or if you're stuck on homework, I'm